All right, after taking a look at simple probability yesterday, some real basics, some things you probably have seen before, we're going to crank things up a little bit today, okay, with compound probability, which basically just means there's more than one event that's going to be occurring, and we have to figure out, what's the probability of each event and what's the probability of those things happening together. So, there's a couple of different options that we have here. So we'll start with the simplest one. A single event with many parts, okay? So again, we're going to be looking for situations where there's an and or an or, and really it's going to basically come down to which word's going on in between on how we're going to handle it. We're going to take a look at both of these situations right now. So for the and situation, okay, both parts must be true. In other words, both parts must happen for the and situation to become possible. Not just one, not just the other, but both. So for instance, for example 1, we're going to draw a single card from a well-shuffled standard deck of 52 cards. Again, if you weren't here yesterday, look over in front of the folders. There's a help sheet there for those of you if you haven't had a lot of experience with playing cards. We'll refer to this a few times today. So we're going to draw a single card from a well-shuffled standard deck of 52. Find each probability. Okay, the probability of a red and a face card. Two separate things that we're putting together. Okay, so when I look here, I'm like, okay, I got to keep all this stuff straight. Face cards are Jack, Queen, and King. Okay, and the red ones are hearts and diamonds. So in this case, for me to get all of those things taken care of, I'd be looking for the Jack, Queen, and King of hearts, and also the Jack, Queen, and King of diamonds. Those 6 would cover me. So there's 6 successes, one of those 6 cards, out of 52 in the deck. And as we mentioned yesterday, whenever there's a fraction, I need to make sure I get it to its most reduced form or its simplest form, which in this case would be a 3 out of 26 chance of that occurring. But again, red and face, not just the face cards, not just the red cards, but the red and face cards. Okay? Same idea working on the second one. Okay? Probability of a card being black. Okay, the black cards are my spades and clubs. And it being a 10. So, you would have the 10 of clubs. You would have the 10 of spades. And do you have to write it out like this every time? No, but I just figured as we're just introducing it to actually go back later and see, what did that mean again? Oh, yeah. So again, black and a 10. The 10 of hearts, 10 of diamonds doesn't help me. They're not black. Okay? The jack of spades, the queen of, spades doesn't help. It's not a 10. So there's only 2 of those in my deck of 52. And I reduce that down to the best of my ability. Okay, so I've got to be able to work those out. Okay, so as it says, you're like, Hardy, the answers were right there all along. I understand this, but again, we wanted to actually be able to talk through how it's coming to be that. So that's just kind of backing it up. And again, we're going to stick with the fraction part. If you went to the decimal percent, that's not a bad thing, but when you're looking at the answers we've got in the key, you'd have to be looking at it that way. For our or situations, again, it occurs if either part or both are true. So I may only get one. I may get both. Sometimes it just depends. Okay? So here, we're going to draw a single card from a well-shuffled standard deck. I'll spit it out of 52 cards. Find each probability. Okay? So here, probability of a red card would be 26 out of 52. You're like, now how did you get that? Because again, hearts and diamonds, red and red, there's 13 of each. 13 and 13 is 26. Then plus my spades, of which there are 13. Okay, and I don't have any overlap between the two. Spades aren't red and red cards aren't spades. So I just add those up and get my probability after I've reduced it, of course. But sometimes you're going to have an inclusive or, like I mentioned up above. We got to do one little different thing to that. So let's chat about that one. So I get to this next one. It says probability of getting a face card. Okay, face cards, there's 3 face cards, Jack, Queen, and King, and there's 4 different suits. So 3 times 4 means there would be 12 face cards. Okay, diamonds are a suit, which means there's 13 of them. Now, normally we would just add these 2 things up, but we have some overlap this time because we have some face cards that are also diamonds. Okay, the Jack, Queen, and King of Diamonds fall into both of these, the face cards and the diamonds. We don't want to count them twice. So any part that falls into both has to be subtracted, and there would be 3 of those cards. Okay, so if you do have overlap, you have to watch for that. We didn't have it in the first one because, again, spades aren't red, and, well, again, spades aren't red. So I go ahead, I subtract those. And go ahead and get that done. Okay, so it's still an or. It still can be either, but I just want to make sure I'm not counting some of the same cards more than once. And again, it says that down at the bottom as well, but I think doing it piece by piece explains it a little bit better. Okay, so over to the back we go. What happens if there's multiple events going on? Okay, to find the probability of the events together, we got to know if the one event affects the other. Okay, so here's how we tell. If they're independent events, 2 or more events in which the occurrence of one has no effect on the other. Now here's an example. Let's say I roll a die and I'm drawing a card. Okay, me rolling a 5 on a die has no effect on which card I'm drawing out of a deck. Just like if I draw the Queen of Hearts, that's not all of a sudden going to make one of the numbers on the die more likely. They're independent events of each other. However, when we look at dependent events, one will have an effect on the other. For instance, what if I ask the chances of drawing 2 kings consecutively without replacement? Well, if I draw the first king, not only are there fewer kings in the deck now, there's also fewer cards. So that first draw had an effect on the probability of me having the second event occur. Direct connection. So cards is one where we'll see this a lot. Or sometimes if you're drawing items out of a bag and you take that first item out and you don't put it back in. Okay, that would make it dependent on what we were doing. Which brings us to a little preview of what will be coming again in a little bit more detail in a later lesson. Conditional probability. The probability that if event B occurs, that the event A has also occurred. That's what happens with our dependence. So it can be called the probability of B given A. And again, we'll get more into that discussion a little bit later. But in general here, when we're looking for the probability of more than one event occurring, we multiply the separate probabilities of the individual events together. So if 3 different things go on, we multiply the 3 different probabilities together. 2 events, multiply the 2 things together. And again, it's just a little bit different whether we're doing dependent or independent. We still multiply, there'd still be 2 values. I just have to pay attention that once the first event happens in dependent, that I take that into consideration in the second part. And we're going to discuss that here in just a second to clean that up because it looks weird with all the different ways that they're written down here. So let's jump in. So example 3. We got 15 marbles in a bag. 5 are blue, 3 are red, 7 are clear. If a marble is pulled from the bag, replaced, and then a second marble is pulled out. This actually would be an example of an independent event. You're like, well, why is it independent? Because once I took the marble out of the bag, I put it back in for the next one. So there were still 15 marbles I could pick from. It would be different if I took the marble out and I kept it, because then there'd only be 14 marbles, and that changes things. But it's replaced, so that's an important word to look for. So here, I do the probability of blue. There's 5 blue ones out of 15 marbles in the bag. I put the blue one that I pulled out back in, so there's still 15. Then I pull in again, and I'm seeing if I can get a red one, which would be 3 out of 15. And then basically, we just multiply across. Okay, this isn't addition. Don't leave the denominator as 15. You actually multiply straight across. And then, of course, reduce the fraction as much as you can. And get to my answer that way. And again, that's even true if it's the same type of marble that I'm looking for. Okay, the probability of getting a clear one, 7 out of 15. I take that clear one, I put it back in the bag. Well, if it's then clear again, it's just the same thing. And again, we just multiply across. Try to reduce it. If it reduces, that's fine. If it doesn't, that's fine as well. We may get some big fractions sometimes that they don't reduce. And again, answers down below, but it's letting you see how we did it. And you may notice here, if you can see it better on yours right in front of you, you can sometimes, no, it's not time to leave. You can reduce your fractions right away and then multiply across. You can reduce right away, or you can reduce at the end like we did, and we'll get the same answer either way. But still, we're going to try and stick to the fractions for the most part. Now, here comes a slight change in word. Okay, again, we have 15 marbles in a bag. Same number of blue, same number of red, same number of clear. If a marble is pulled from the bag, and then a second marble is pulled out, okay? So here, we're doing it without replacing it. Once that first marble's out, it's out. This would be an example of dependent events. You're like, well, why is that? Okay, notice we're looking at the same 2 examples, but we changed the one word. Well, the one phrase. So I look at my probability of blue. That hasn't changed. 15 marbles in the bag, I'm looking for a blue one. There's 5 possibilities or successes. However, now, when I go to reach in again, now there's only 14 marbles because I didn't put the blue one back. It didn't say I replaced it. There's still only going to be 3 red ones. But once again, I have to make sure that I remember that, because that's going to change my answer at the end. And I worked that out. Okay? So a dependent, my odds changed up a little bit. Excuse me, my probability did. And then clear with clear. Now here I really got to be careful. My first one will still be the same. There's 7 clear, there's 15 total. But if I keep that clear one out, not only do I lose one from my possibilities in the bag, but there's also one of the clear ones have disappeared as well, so there's only 6 now. Okay? Take that clear one out, it reduces in this case from both my successes and my total. But I still would multiply that across and get my value. Okay, and again, same thing is written down below. I'm not quite sure why they go into all of the turning this all into factored form. I guess you could, but yeah, probably not. So your job with this is going to be the Probability 2 worksheet. Again, just like yesterday, we've only been going about 15 minutes here. So you've got a good chunk of time here, almost half an hour, to go ahead and get that worksheet knocked out. The keys up front, check as you go. Star ones you're not sure on, and let's chat about them tomorrow if we need to do that before we get ourselves rolling a little bit more into this, into the theoretical part of things. So do a good job with this, keep practicing, and I'll see you soon.